Okay, we're going to wrap up 5.2 here, looking at the rest of our trig integrals, some new ones for this semester. Last semester we learned 6 of them. Okay, so the 6 that we already know are the integral of sine, the integral of cosine, the integral of secant squared, and the integral of cosecant squared, the integral of secant tangent, and the integral of cosecant cotangent. Okay. We have a couple more here that we need to learn, 4 in particular that we're going to be looking at today. The first one is the integral of tangent u du. Okay, the integral of tangent u is one of 2, and we'll talk about here why they're technically the same, negative natural log of cosine u, or the natural log of secant u, plus c, of course. And I know that those seem, potentially speaking, like they might be different, but they actually aren't. Remember that if we have a coefficient in front of a natural log, I'm technically able to bring that coefficient up as an exponent. And so for if I were to do that here, bringing that negative up as as an exponent, so bringing that negative 1 up above, cosine u to the negative 1 would be the same thing as 1 over cosine u, which is what secant is. And so while these, like I said, look different, they are technically the same, but we do need to be able to recognize them both. Both are the integral of tangent u because they're technically the same thing. Okay, second one, integral of cotangent u is the natural log of sine u. Okay, both of these rules come out of rewriting tangent as being sine over cosine, or cotangent as cosine over sine, and doing a u du substitution on the denominator. And that's how you get these 2 rules. I'm more than happy to demonstrate that the next time I'm in class if you would like to see it. For now, we're just going to stick with the rules. Our last 2 here come out of, are the integral of secant u du, which is the natural log of the absolute value of secant u plus tangent u, and the integral of cosecant u, which is negative natural log of cosecant u plus cotangent u plus c. Okay, so these are our 4 new rules here. We do need to have them memorized. We are going to quiz ourselves starting the next time in class, actually, on our different derivative and integral rules. As we continue through this unit, we're going to add in more. Okay, but for right now, we're going to start with just practicing these particular integral rules, and then I have some kind of cumulative integral practice for the rest of the video for however much time there is left in class. So starting with here, we're going to look at example 1. Let me slide this up. We have the integral of secant 4x minus 1 dx. So we're going to do this one together. A reminder back from first semester, our trigs, we only know integrals of the trig with a singular variable in it, right? Cosecant u, secant u, etc. Meaning singular, if there's anything inside of my trig with my variable, I have to do a u du substitution on that piece. So for this first example here, when I identify that, like, you know, this looks like it's going to be this rule here, integral of secant u, because I have a 4 and a minus 1 inside with my variable, I do need to do a u du substitution on that piece. So my u would be 4x minus 1. My du then would be 4 dx. I do not have that coefficient within my integrand, so I am going to divide that 4 over to the other side, and I can do my u du substitution on that piece. Okay, so the dx is going to come out. It's going to be replaced with 1/4 du. and do that. 1/4 du. The 4x minus 1 is going to come out and be replaced with u. So we've got our u here instead of our 4x minus 1. Now that secant was not used anywhere in my u or my du, so it's going to stay with the u, secant u. And that's a rule that I know. Okay. The integral of secant u, 1/4 a coefficient, the integral of secant u is the natural log of secant u plus tangent u. Absolute value of secant u plus tangent u. And then if I substitute my u back in, my u is 4x minus 1. So we get the secant, absolute value of secant 4x minus 1 plus tangent of 4x minus 1. And that's my answer. The other thing you might look for is this 1/4 to have been brought up as an exponent there. Okay, so we're going to practice a couple more of these here. Example 2 is going to be the integral of 3t squared plus tangent t dt. I'm going to have the sub pause the video at this point, and then you're going to try it on your own as soon as it seems like people have reached a stopping point, whether that's they are stuck or they have an answer. Go ahead and restart the video. I'll walk through how to get to that answer, and we'll proceed from there. So go ahead and pause the video. Okay, so example 2, looking at this one, 3t squared, or I'm sorry, the integral of 3t squared, that's power rule. I don't have to worry about anything there, so I'm going to add 1 to the exponent and divide by the new exponent. Tangent t, that's an integral rule that I now know, and I do need to have that memorized. Because it's a singular variable, I am allowed to just apply the integral rule, and so the integral of tangent is either the natural log of secant, or potentially speaking, oh, and I'm going to simplify those 3's here, or potentially speaking t cubed minus the natural log of cosine. And so you'd be looking for one of those two answers. Okay, let's do another trig one here. Example 3 is going to be the integral of negative cotangent 2x dx. Okay, go ahead and pause the video, restart it when it looks like people are ready. Okay, so this is a trig rule that I know. I know the integral of cotangent. Negative's a coefficient, so I'm going to be able to just let it hang out. But I do know the integral of cotangent. However, I only know the integral of cotangent of a singular variable. And so I am going to need to do a u/du substitution on that piece. So my u is going to be 2x. My du then would be 2. Now the 2 is not part of my integral, so I am going to divide that 2 over. The other thing you need to decide is, do you want to multiply by a negative? If I multiply by a negative, that negative would come out, technically speaking, through my u/du substitution. If I don't multiply by a negative, the negative is going to stay with my integral. It's totally personal preference. I'm just going to let the negative hang out. Okay, and so I'm going to pull out the dx and replace it with 1/2 du. Okay, I'm going to pull out the 2x and replace it with u. The cotangent will also hang out because the cotangent didn't come out through my u/du substitution. Okay, and then the integral of cotangent, I'm going to let that negative 1/2 hang out. Integral of cotangent is the natural log of the absolute value of sine u plus c, which is the natural log of sine 2x plus c. And so that would be your answer. Other things to potentially look for would be that negative 1/2 being brought up as an exponent. So sine 2x to the negative 1/2. They also could potentially write what that negative 1/2 is. The negative would make this sign go down to the denominator if the negative was up as an exponent. Okay, let me actually show that. Natural log of sine 2x to the negative 1/2. Okay, so that negative would cause this sine x to go down to the denominator, and the 1/2 would make it a square root. So this could potentially be written as 1 over root sine 2x plus c from that exponent piece. Okay. Okay, with that, we are going to enter into some spiraled practice, because again, we don't want to constrain ourselves too much to just our integrals. So the rest of the period, however much that's going to be, is going to be potentially trig integrals, potentially long division, natural log, power rule. Again, the goal is to try to figure out like what might I be doing in this particular instance. And so we're going to follow the same format of me putting an example problem down, and then the sub stopping the video or pausing the video so that you can give it a shot, restarting when it looks like people are stuck or have an answer, so that we can walk through how it's done. Okay, so some cumulative practice here. Let's start with, what are we on, example 4. We're going to do the integral of secant squared x over tangent x dx. Okay, pause for a moment, see if you can figure out what it is on your own, then check it with your partner. The video will be paused. When you guys are ready, the sub will restart the video so you can check your answer. Okay, on this one we have to be doing some sort of u/du substitution because there's no chain rule within an integral, there's no quotient rule within an integral. And I actually do know the integral of secant u, or sorry, secant squared u. But I don't know the integral of secant squared u over tangent, and that quotient rule is an issue. So if I were to do u/du substitution, you could potentially try a variety of things, but remember we want to look for our parentheses. In this case, we technically speaking have 2 sets of parentheses. One set is here. This could be rewritten as secant x in parentheses quantity squared. Or this could be written, this is the second set, as tangent x in parentheses quantity to the negative 1. And in this particular case, my u is going to be the tangent x because my du, the derivative of tangent, is secant squared. And because that is within my integral here, I know that that is the correct u/du combination. And so my tangent x would come out and be called u. It's going to stay in the denominator because I never had a denominator as part of my u/du substitution. The secant squared x dx is going to come out and be replaced with du. And that's a rule I know. We learned this on Thursday. Integral of 1 over u du is the natural log of the absolute value of u. And in this case, my u is tangent x. And so there is my answer. Okay, next one, example 5. We are looking at the integral of 5x squared minus 1 over x cubed dx. So same thing, you're going to think for a moment, figure out what you would do, check it with your partner. Sub will stop the video when you guys are ready to have it restart. Restart the video and check your answer. Okay, so this one here, 5x squared is just power rule. So I can add 1 to the exponent, divide by the new exponent. Oops, sorry, 3. This one's potentially a little bit tricky. It's tempting to want to call this the natural log rule because the integral of 1 over u is the natural log. However, this is not 1 over u because this is x cubed. We are not 1 over u cubed. It's just 1 over u. This is actually power rule as well because x cubed can be rewritten as x to the negative 3. And I am able to add 1 to the exponent, so that minus will stay. Add 1 to the exponent, we get x to the negative 2, and divide by the new exponent. So this just happens to be power rule. 5/3 x cubed plus 1 over 2 x squared. Okay, next one, example 6. The integral of, let's do 9x squared plus 18x plus 6 all over x cubed plus 3x squared plus 2x dx. Go ahead and pause the video, give this one a shot. Okay, with a problem like this one, quotient rule does not work, rewriting as a negative exponent doesn't work. Every once in a while I see people try to do long division on this one. However, if you remember from our last lesson, long division doesn't work in this case because for long division to work, my numerator's highest power has to be greater than or equal to my denominator's highest power. And in this case, my numerator's highest power is 2, my denominator's is 3. And so I cannot do long division. This one does get solved through UDU substitution. So looking for your parentheses, my parentheses in this case are around the denominator. This is x cubed plus 3x squared plus 2x, quantity to the negative 1. And so if I make my u x cubed plus 3x squared plus 2x, my du then would be 3x squared plus 6x plus 2. And while it might seem initially like that's not within my integral, it actually is. This is a modified version of my numerator up here. Because if I multiply both sides by 3, my 3x squared would become 9x squared, 6x would become 18x, and 2 would become 6. Remember, you can always manipulate your coefficients. So this is UDU substitution. My 9x squared plus 18x plus 6 dx comes out and is called 3 du. And my x cubed plus 3x squared plus 2x comes out and is called u. Because that's in the denominator, and the denominator was never used in my u or my du, the u will stay in the denominator. And that's a rule. The integral of 1 over u du is the natural log of the absolute value of u. My u in this case is x cubed plus 3x squared plus 2x. The other thing to look for would be this 3 brought up as an exponent. Okay, next up we've got example 7. The integral of 3x squared minus 5 all over x minus 2 dx. Go ahead and pause this video, give this one a shot. Okay, so this one, variety of things you might have tried, potentially a UDU substitution. We have to get rid of the quotient rule. Unfortunately, rewriting as a negative exponent doesn't allow me to FOIL, so that wouldn't work. So in this particular case, you might try a bunch of things, none of them work. And so this would be an instance for long division. Okay? In this case, my numerator's highest power is greater than or equal to my denominator's highest power. And so I could do long division here. Okay. So the question is, well, how many times does x go into 3x squared? Or another way to ask that question, x times what gives me 3x squared? That'd be 3x. And so multiplying 3x times x is 3x squared. 3x times negative 2 is negative 6x. And then we're going to subtract, so this becomes negative 3x squared plus 6x, which would leave me with 6x minus 5. How many times does x go into 6x, or x times what gives me 6x? That would be positive 6. 6 times x is 6x. 6 times negative 2 is negative 12. And then I'm subtracting, so this becomes minus 6x plus 12. Negative 5 plus 12 is 7. How many times does x go into 7? Or x times what gives me 7? That doesn't work. So this is my remainder. And so I'm writing this 7 above this x minus 2 to give me 7 over x minus 2. And so that's my new integrand. We have 3x plus 6 plus 7 over x minus 2. The integral of 3x, that's power rule, so we're going to add 1 to the exponent, divide by the new exponent. Power rule, integral of 6 is 6x. And then just for a bit here, I'm going to rewrite the 7 over x minus 2. You don't have to do that step, but I'm going to because for some people that's easier. This is technically speaking a u/du substitution. But also for the record, you don't have to because look at what my du ends up being. I should say you don't have to show that because look at what my du ends up being. My du ends up being 1. Well, 1 has no impact on this particular integral. If this was a 3 or a 5, that might potentially change my integral, but 1 doesn't. And so I could potentially just skip this u/du step. I am going to show it, though, just for those who need that consistency. Okay, so my 7, I'm going to let my 7 hang out. I also could multiply both sides by 7 to make it match, but I'm going to let it hang out. The dx comes out and is du, and the x minus 2 becomes u in the denominator there. And the integral of, sorry, one second, the integral of 1 over u is the natural log of the absolute value of my u. So if you look there, this is why we don't necessarily have to show the u/du substitution, right? If I had just looked at this and said the natural log of x minus 2, I still would have gotten the same answer. Only, again, because my du is 1. Okay. I'll go ahead and put up the next one, example 8 here. Let's do the integral of, let's do x squared plus 3x plus 5 all over x plus 1 dx. Go ahead and pause this video and give this one a shot. Okay, so again, you might have tried a variety of things. In this particular case, they would all fail except for long division. This is another long division one there. So my x squared plus 3x plus 5 would be inside the little division house, x plus 1 on the outside. Okay, so how many times does x go into x squared, or x times what is x squared? That would be x. X times x is x squared. X times 1 is x. And then we're subtracting, so that's minus x squared minus x. X squareds cross out. We have 3x minus x, which is 2x, and the 5. How many times does x go into 2x? Or x times what gives me 2x? That would be positive 2. 2 times x is 2x. 2 times 1 is 2. And I am subtracting, so minus 2x minus 2. And 5 minus 2 is 3. X does not go into 3, and so that's my remainder. We have our 3 over that x plus 1. That is my new integrand. So we have x plus 2 plus 3 over x plus 1. This is power rule. So add 1 to the exponent, divide by the new exponent. So x squared over 2. Power rule. So 2x. And then again, I'm going to rewrite this momentarily. Again, technically speaking, a u/du. And again, not one you have to show because your u is 1. So it has no impact on my integrand. 1 doesn't do anything. Although again, you want to be careful about skipping this step if my du is something else. So we have 1/2 x squared plus 2x plus the 3 is going to hang out. Dx comes out as du. X plus 1 is u in the denominator. The denominator was not part of either my u or my du. So we have 1/2 x squared plus 2x plus 3, integral of 1 over u is natural log of the absolute value of my u. Okay. Example 9. We have the integral of 2x minus 1 over the quantity of x squared minus x minus 6 squared dx. Go ahead and pause this, give this one a shot. Okay, this particular case, definitely a u to u substitution. And it works out pretty nicely because my u would be my x squared minus x minus 6. Du then would be 2x minus 1 dx. My 2x minus 1 dx would come out then and be replaced with du. My x squared minus x minus 6 would be called u. It is in the denominator, and that squared was never used, so that squared stays. Okay, you want to be careful here. It's tempting to call this the natural log rule, but it's not. Remember, natural log is 1 over u, not 1 over u squared. Singular variable, so this is actually a power rule. 1 over u squared is u to the negative 2. If I add 1 to the exponent then and divide by the new exponent, and then substitute in my u, get my answer of negative 1 over my u plus c. Okay. Example 10. Let's do the integral of x to the 4th minus x squared plus 1 all over x squared dx. Go ahead and pause the video, give this one a shot. Okay. Different things you could potentially do here. This one you could do long division on if you wanted to. X to the 4th minus x squared plus 1 inside the house, all of that. But this one actually, you don't have to do that because I could rewrite this x squared as x to the negative 2. And because I have a singular denominator down here, I can do that, and that allows me to distribute. So x to the negative 2 times x to the 4th is x squared. X to the negative 2 times x squared is 1. And x to the negative 2 times 1 is x to the negative 2. And this one is power rule. So adding 1 to the exponent, dividing by the new exponent all the way across here. And cleaning this up, you'd have your answer 1/3 x cubed minus x minus 1 over x plus c. Again, technically speaking, you could do long division. It would result in the same answer. It's, I would say, probably a little bit more work than just rewriting as a negative exponent, but you could. It would work out. Okay, one more for this cumulative practice here. Let's do example 11. We're going to do the integral of tangent 5x. I'm sorry. Rewrite that, sorry about that. Okay, x squared times the tangent of 5x cubed dx. Go ahead and pause the video and give this one a shot. Okay, so with this particular one, our trig here, integral of tangent, I know the integral of tangent. It does have to be the integral of tangent singular variable though, and this is definitely not a singular variable in here. So if I was going to do integral of tangent, I'd have to do u to u substitution on this piece. You definitely have to do some sort of manipulation because there's no such thing as product rule or chain rule within an integral. Okay, so let's see if that u to u substitution would work on 5x cubed. Du then would be 15x squared dx. And I do have the x squared dx in there. I don't have the 15, but I can rectify that by dividing the 15 over to the other side. And so I can do my u to u substitution on that piece. The x squared dx would come out and be replaced with 1/15 du. The 5x cubed would be called u. The tangent is staying because it was never part of my u or my du. And this is the rule we wrote down at the beginning, or one of the rules. So this could be the natural log of the absolute value of secant u plus c. So you might see that. Or potentially negative natural log of the absolute value of cosine u plus c. So you'd be looking for one of those two answers. And we're going to stop there for today.